Saxon's Calculus, Lesson 47, is about critical numbers. Now, they take a great deal of time on page 237 and 238 to walk through a lot of information that I didn't find extremely helpful. I found it more confusing than helpful. However, they do talk about remembering that limits can approach from the left-hand side or from the right-hand side. And we can have an absolute, like y equals the absolute value of x. So on page 238, they show you that the graph of y equals the absolute value of x is a V shape. And then if you do the derivative of that and graph it, you end up with an open circle, arrow, and arrow this way. So it's its own unique graph when you do the derivative. And then in bold words, I feel like this was a little more helpful. For the reason illustrated here, any function whose graph comes to a sharp point does not have a derivative at that x equals c for the constant. All right, and then they go into this graph where you've got all kinds of swoops happening, something along that line. And they're saying that at each of these points, we have slopes that are 0, and so they are important spots on the graph. So we would call them critical numbers. And one of them will be the highest one, and it will be the local maximum point. One will be the lowest one, and it will be the local minimum point. And they use another word for those, which is stationary points. Now, on the top of 239, you encounter a box, and it gives you this definition. A critical number, or a value or a point of a function, is a number, an x dot position, for which the derivative equals 0, or for which the derivative does not exist. So again, that's their definition for all these places where your slope is going to be 0. In example 1, it says, find the critical numbers of this function. F of x equals x cubed plus 9/2 x squared plus 6x plus 5. Also find which is the relative maximum and minimum. So we're going to derive to find the critical numbers, the places where I would have peaks and low points or slopes that are 0. So to do that, we're going to derive. So then that's going to give us 3x squared. And then when I multiply this 2, it cancels with the denominator. So that just leaves me with 9x plus 6. And of course, the 5 drops off. And we want to set this equal to 0. Now, can we factor that? Well, before I do that, I see that all the numbers will reduce by 3. So let's do that first. X squared plus 3x plus 2 equals 0. Now let's see if we can factor it. X and x, 2 and 1. The 2 is larger, so its sign must match the middle, which is positive. How do I go from 2 to 3? I add another one, and I always double check. Positive times positive is positive, so this is correct. So my critical numbers are -1 and -2. And then I will plug those back into the original to see what values they give me, because one of this will be the maxima and one will be the minimum. And if I had more than 2 points, one of them wouldn't be the max or the min, it would just be a critical point. So when I plug in -1, we get -1 plus 9/2 minus 6 plus 5. Okay. I'm going to go ahead and make that -1 and that -1. So that's -2 plus 9/2. So then my common denominator makes that -4. So 5/2 is the matching value with the -1. So like that would be its coordinate point. And then when I plug in -2, 4, -8. So -24. I was plugging in -2. 4. 2 goes into 4 twice, so that's plus 18 minus 12 plus 5. 2, 3, so -6, 18, 17, 16, 15, 14, negative 13, unless I've made a boo-boo in there. Uh-oh. When they plugged in negative 2, they got 3. When they plugged in negative 1, they got, oh, well, I have the 2.5 right. Okay, I've done something wrong on negative 2. Okay, let me try to, oh, I'm guessing it's got to be my negative 20. No. This one. Oh, see, that didn't, okay, bummer. Negative 2 times negative 2 is positive 4. Oh, good gravy. Here it is. Yep, it was that first number. Positive 4, negative 8. Oh, my goodness. Okay, let me see if that fixes it. That would be positive 10, negative 2, positive 3. Yes. All right, that was my problem right there. So now I have the 2 coordinate points. Which one is higher, the 5/2 or the 3? Well, by just a smidge, the 3. So that means that this negative 2, 3 is my maximum, local maximum point, and this one is my local. I should write that. Local max and local min points. Okay, example 2. Find the critical numbers of the function f of x equals 1/4 x to the 4th minus 1/3 x cubed minus x squared plus 5. Indicate where the relative maximum and relative minimum, oh, I called it local max and min, but they're calling it relative, same. So we're going to derive again. So 4 multiplies and cancels off, so that gives me x cubed. Same thing happens again here, so minus x squared minus 2x, and of course the 5 drops off. We're going to set that equal to 0. They all share an x, so we're going to factor that out, leaving x squared minus x minus 2 equals 0. The x is still there, so then this should x and x, 2 and 1. 2 is the larger, negative in the middle, so how do I go from negative 2 to negative 1? I add 1. Positive times negative is negative, so this is a correct factoring. So now I have 0, negative 1, and positive 2 as critical numbers. And then I need to plug those in and see which is coming out. So 0 is easy. That gives me 0, 5. Negative 1, that's going to be positive 1, so 1/4. Negative 1, so that's negative 1, so that's positive 1/3. Negative 1 squared, so that's negative 1. I was thinking I could do the common denominator, but I can't. Plus 5. That's going to be plus 4. Common denominator's 12, which I hate to do. All right, so that one's 3, that one's 12, that's 4. 12 goes underneath this one, and 4 times, that's 48. Okay, so 4, 5, 6, 7 minus 48, is that 39/12? I think. Negative 1 and 39/12, which is like 3 and something. Okay. I don't really have room to say 3 and something to help me remember when I come back. And then plugging in the 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. 16 divided by 4 goes back to 4, minus 2 times 2 is 4, times 2 is 8, so minus 8/3, minus 2 squared is 4, plus the 5. Okay, so again, that's a 1. 4, that was a positive 1. So 4 plus 1 is 5. So we've got 5 minus 8/3, common denominator 3, that's 15. So 7/3, 2 and 7/3, unless I've made a calculation error. So my biggest one is going to be the, yeah, that's 2 and something, so that's smaller than that one. So the 0, 5 should be my max. I'm looking for that answer. And then, yeah, so then this one is the smallest, so it is the minimum. And the reason they did not show you plugging these in, as I was doing here to get the math to actually find them, what they said was, if I mentally picture the graph of, and I just find it a little bit faster to just plug my numbers in, but you can do whatever. I'm going to finish walking through what they did with the graph. So they said since our highest exponent value was 4, we can have up to 3 curves, and they can be in a variety of ways. And if you're looking at your book in example 2, you see all of their graphs of the variety of ways that they can do it. And so then they said, just kind of intuitively, that means that the maximum has to be at 0 because it's in the middle and it should be about the average of the things. And then they said to them it was obvious that the minimum value should be at the 2 just because of the way the points fall in their swooping, because overall this is positive, so all of their graphs are like W shapes heading upward. I don't think it's intuitive. I would rather do the math, but whatevs.